sodium, carbon, hydrogen, and oxygen. Osiris is far too hot for life as we know it.
There may be other forms of life, however, that thrive on higher temperatures.
But there's no solid surfaces we know on a hot Jupiter. So this life would have to be just tiny little microbes floating around on aerosols. And on our own Earth, we have life that floats around in our atmosphere. But that life didn't start there. So life almost certainly would not exist on hot Jupiters.
Astronomers have discovered many hot Jupiters since Bellerophon was found in 1995. But conditions on these worlds rule them out as places where the drama of life can unfold. Huge icebergs calve into a stormy and fast-rising ocean. For two preciously short periods, during the spring thaw and the autumn rains, the
We're gonna see what Michael does if Franklin doesn't follow the rules.
At a distance of 93 million miles from the star, roughly the same distance as from the sun, the elliptical orbit of this planet and its moon crosses an area around the star some scientists call the Goldilocks zone. The conditions here are just right for life.
If you're too close to the star, then it's too hot. If you're too far away, then it's going to be too cold and everything's going to be icy. But then if you're right in the middle, it's just right.
As these animals on the Earth during the winter season. If this sounds fantastic, I offer you the tidal zones on the Earth. On the tidal zones, life proliferates, of course, near the seashore, and they do so despite tides. The water coming in, covering many of the life forms, the water going out at low tide, and yet those species survive perfectly well.
The strange cycle of the yo-yo planet's orbit creates fleeting conditions suitable for life, but also for death. Some alien planets are even more bizarre. Imagine a world that has no star to orbit. Scientists speculate that our galaxy is teeming with rogue planets, adrift in the murky lanes of interstellar space. These are orphaned worlds, planets that are booted from their solar systems by the chaos of planetary migration. Astronomers call such worlds planemos.
Planemos are planets without a star. They're just drifting through the galaxy indefinitely.
What massive force would it take to kick a planet out of the solar system?
When a young star forms with a contingent of planets around it, many of those planets gravitationally interact with each other. They blink on each other, slingshot each other, so that one of them is ejected from the planetary system, floated off the island, if you will.
If you were, fortunately, a resident of the planet that was kicked out,